1, whatever, what, are you okay? Do you need something?
No, I just was wondering.
Mass of 1 mole of that element, G divided by mole.
Thank you.
G stands for grams, M's mole, MOL stands for mole. With the E.
Wait, I got a question.
MOL is an abbreviation
that's
for
not my question.
mole and an E, but not to be confused with the thing that apparently doesn't grow on your grandmother's
That's not my
face.
question, sir.
Yes.
What is that a 1? Like in the,
You can
okay, top, where it says 6.02. Is that 1? Thank
Bring
you.
my lasers. I'm fine.
Okay, so when we're balancing reactions, we have to know how much of each thing we're going to use. In that case, we can't be like, oh, here's 1 atom of sodium. Here's 1 atom of chlorine, especially because chlorine is usually a gas. Oh, let's mix it. Cool, we have salt. Like, it doesn't work that way. You usually have much larger quantities, and we go by moles. How do we know how many moles we have? We go by weight and the atomic mass. So let's try a practice problem. How many atoms are in 4.5 moles of helium? Hint, you do not need to look up the atomic mass of helium because we only want to know how many moles are present in or how many atoms are present in 4.5 moles of helium. This is a unit conversion problem. You start with 4.5 moles. What do we put it over, Andrew?
Grams. Mole.
It's a number.
1.
1.
Oh.
Nothing goes there. Then we are multiplying by something. We want to cancel out moles, and we want atoms. What something do I multiply by? It's the only other thing on the board with a number.
Oh, that thingy.
The atomic mass
A
of helium.
Vargo's number.
Avocado's number.
Wait, no, I pointed at him. You got to give the chance for redemption. He can redeem his answer, the correct one, which is.
Avogadro's number.
That's right. We're going to use Avogadro's number. Why? Because it relates atoms. Sit up, sit up. It'll help you stay awake through my boring, monotonous voice in class. I understand. This relates atoms and moles. So of course I'm going to use the conversion that relates atoms and moles. So 6.022 times 10 to the 23rd atoms per 1 mole. If I multiply those, I get 2.7 times 10 to the 24 atoms. Remember your significant digits. If they only give you 2, your result should only have 2 because you're multiplying. Okay. Now, what happens if I have 16 moles of, I don't know, hydrogen? Let's not do hydrogen. Sodium. How many atoms do I have? Go. The writing, the calculating. You need a calculator. Just sure things not. So to get that times 10 to the, you use a little e button. Times 10 to the 23rd. And you're multiplying that by 4.5. All right, the answer is
10 times 24. I got that. 20.
9.6 times 10 to the 24th.
Wait, 9 points.
So 16 moles over what?
Over 1.
1 times 6.022 times 10 to the 23rd atoms per 1 mole. Moles cancel, just like when you go to the dermatologist and they remove it from growing on your face.
With the laser.
Yep, that's right.
Oh,
You know what? I can't help you people. Then you get 9.6 times 10 to the 24th atom. Important note, you probably have never used this button on your calculator because you just do times 10 to the 23rd. There's a button for that. It's called the little E button.
Oh.
You'll notice it above the comma.
I don't have a. I have a
Oh.
Casio.
That's
Yep.
fun.
Yeah.
Good luck. It's somewhere.
But then when you set up.
Okay, so this is your times 10 to the.
Wait, would it be the E at like E to the power of X?
No.
That's not it.
I think you have a times 10 to the button. Yeah. It should be near the E.
Okay.
Should be above the log one. So that you can do 16 times 6.022 e to the 23rd, and that'll get you the same result. So that's an easy way to do it. All right, your homework is already on the board, so enjoy.